Hi everybody. Today we're going to talk about 4.3. I'm kind of going to skim through it a little bit towards the end. I don't think this stuff is as important as some of the other stuff we've talked about, and I'd rather have you focus on some other sections. So basically what's going to happen, we're almost wrapped up, so we're going to post 4.3 today, then 4.4 at the end of the week, and along with posting 4.4, I'm also going to post your final test. Now, it's really important that those get back to me because your final grades are due next week. So the sooner you can get back to me with those and any work you've had throughout the semester, please just get them to me as fast as you can. I'll compile them and I'll give you your final grade. But again, like I've said a couple times throughout the semester, as long as you turn in everything to me, I wouldn't be worried about the content itself. Everybody's been looking pretty good in terms of what I've been able to see on their content. If you have specific questions, let me know. But otherwise, just keep trucking and keep on posting everything you can, and we'll get through it together. So let's start on 4.3. This is equations and inequalities involving absolute value. So let's look at solving some absolute value equations. We have taken the absolute value of numbers before. We know that it's the distance away from 0. So let's look at something like this. If we have something like the absolute value of x equals 3, we want to know how many answers there are for this. So we want to know how many things can I plug in for x to make it work? Well, what can I plug in? What's the absolute value would equal 3? If I plugged in 3, the absolute value of 3 equals 3, that's one answer. But if you consider that I could also plug in negative 3, right? Negative 3, the absolute value of negative 3 is going to be 3 as well. So this is going to have two answers. So absolute value equations are going to have two answers. They're going to be the positive and the negative version. So let's look at this one here. If you ever have to solve an absolute value equation, the easiest way to do it is to pretend that these are parentheses. Okay, we can't break them up until we clean up everything around it. So the first thing I want to do in this case, 3, the absolute value of y plus 5 equals 12. I want to get rid of this 3. So I'm going to divide both sides by 3. And now I have this absolute value of y plus 5 equals 4. From here, I'm going to separate my equation into two separate equations, the positive and the negative. So we're going to say y plus 5 equals 4, or y plus 5 equals negative 4. That's because if you plug either of those into this absolute value, you're still going to get the same answer. So from here, we just solve both of our equations and find out what y can equal. On the left, we're going to subtract 5. We'll get that y equals negative 1. And on the right, we're going to subtract 5 and get that y equals negative 9. And those are your two options. If you plug either of these into the absolute value, you're going to get the same answer. When we plug them both in, negative 1 plus 5 is going to be 4. 3 times 4 is 12. And over here we have negative 9 plus 5, is going to give us a negative 4. The absolute value of negative 4 is 4. 4 times 3 is going to give you 12. So they're both true. So again, if we ever have an absolute value equation, you're going to separate it into two equations, the positive and the negative, and you're going to solve from there. Now let's look at this one. This one, we have two sets of absolute values. So we're just going to take one side, pick either of the sides. I'm going to pick the one on the left, get rid of its absolute values, and now pick the one on the right, get rid of its absolute values, and then make it negative. This way we cover all of our bases, positive, positive, negative, negative, right? And then from here we just have two separate problems to solve. In this case, on the left, we're going to subtract our 5s off. Actually, something simpler. We have this negative 3, or we have this 3x, right? We subtract this 3x over and we get negative 5 equals 5. Is that true? It's not true, right? So on the left, there's no solution. But on the right, we can distribute this negative in, add our 3x over, add 5 over, divide by 6, and get that x equals 0. So in this case, it's an interesting scenario where we have two absolute values, but only one solution. And that's because on the left, we're going to cancel our x's out and get a false statement. So your only answer in this case is x equals 0. Let's try this one. We have the absolute value of 2x minus 1 equals 5. So in this case, we only have one absolute value. So in order to solve it, we're going to simplify it all the way down to our absolute value, which is already done for us. Then we're going to get rid of our absolute value. We're going to make both sides one positive and one negative. So we get rid of our absolute values, make one equal to the positive version, one equal to the negative version. We're going to add 1 over, divide by 2, so we get that x equals 3. And then over here, we're going to add 1 over, divide by 2, and we get that x also equals negative 2. Now looking at this one, we're not quite solved for yet. In order to solve an absolute value equation, you need to simplify down to the absolute value itself. So in this case, we need to get rid of this negative 28 and this times 2. In order to do this, we're going to add 28 over, divide both sides by 2, and now we could split our equation into 2 because we have the absolute value of 1 minus 3x equals 14. So now we can make it 1 minus 3x equals 14 or 1 minus 3x equals negative 14. From here, we subtract our 1 over, divide both sides by negative 3. You get that x equals negative 13 thirds or x equals 5. Let's think back. What do we do if we have two sets of absolute values? Well, if they're both simplified for, we're going to set one on the left. The one on the left is just going to both be positive. Then the one on the right, we're going to make one positive and one negative. Then we're going to simplify, so we'll add 7, divide by 2, or actually all we have to do in this case is add 7 and subtract the x over. So in the left case, we get the x equals 10. On the right, we have to distribute our negative sign. So we get that x times the negative is a negative x, then negative 3. So in this case, we're going to add our 7 over and add our x over. We have to divide both sides by 3, and we get that x equals 4 thirds. So it gives us two solutions, 4 thirds and 10. Now let's look at some inequalities. Just like we did equations, and then we translated them to inequalities, we do the same thing for absolute values. So sometimes taking the bar off for an absolute value usually leads us to write two separate equations to solve. We've also seen that often we get two different numbers when we solve absolute value equations. But when we look at inequalities, we'll expect that we're going to get different intervals. So for solving absolute value equalities from the point, if it starts out the absolute value is less than c, then all we do is just put the negative c to the left of it. And that's also true if it's or equal to. So in this case, if we have the absolute value of something is less than or equal to 20, all we have to do in order to solve it is get rid of your absolute value and put a negative 20 on the left. And then we solve it just like we did in section 4.2. From here, we would subtract 2 from everything. Remember, it's not from both sides right now because we have actually 3 sides. So, okay, they distribute first. That's fine too. So you can distribute first, then you do negative 3 plus 2 gives us a negative 1. Then we're going to add 1 to everything. So it cancels out in the middle, but gets you negative 19 over here, gets you 21 over here. Then divide everything by 3, and you'll get your interval. This is your solution right here. Negative 19 thirds is less than or equal to x, which is less than or equal to 7. So I'll take any of these denotions. I'll take what I just showed you. I'll take just this bit in the middle here, or negative 19 thirds comma 7. Those are all fine. Let's try another one. In this case, we have the absolute value of x minus 2 is less than 5. So in order to solve this, we're going to get rid of our absolute value, and we're going to put a negative 5 on the left. So we get rid of the absolute value, put our negative 5 on the left. Then from there, we can add 2 to each portion. So it cancels out in the middle. 5 plus 2 gives us 7. Negative 5 plus 2 gives us a negative 3. And then we have our solution. I'll take this as the answer. I don't need much more than this, unless it specifically says to graph it, in which case just put a little parenthesis at the 3, parenthesis at the 7, and shade the middle. Now looking at this one, like I just said a little bit ago, in order to solve these absolute value equations, you have to get the absolute value by itself first. So in this case, we're going to have to add this 20 over. So actually, we're going to have to subtract this 20 over. I'm sorry. We subtract this 20 over, and then we have to divide by negative 3. And remember, when we divide by a negative, we flip our sign. So we divide this negative 3 from both sides. So we get negative 39 divided by negative 3. We flip our sign, and now we have 5x minus 2 is less than or equal to 13. Now we can get rid of our absolute value symbols and put a negative 13 on the left. Then from there, we add positive 2 to everything. Divide everything by 5, and you get an answer that's got some fractions in it, but like we've seen before, that's not okay. Now let's look at the opposite side. These all had less than symbols in it. Let's see what happens if we have a greater than symbol. Essentially, that and or portion we had talked about are really going to be the same thing as this. So the less than symbols translate kind of like an and statement, but the greater than symbols are going to translate to an or statement. And that just means we just have to do two separate problems, and it's really not much harder. So in this case, if we have the absolute value of x minus 2 is greater than 5, we're going to rewrite it without the absolute value bars. And the important part is when you make one of them negative, you also flip the sign. So in this case, we translate our original problem. We get rid of our absolute values. That looks like right here. So in one case, you just get rid of the absolute values. In the other case, you get rid of the absolute values and flip them. So if it's greater than, you have to flip them. Now you just solve them compound. You're going to add 2 to both sides, add 2 to both sides, and you get that x is less than 3 or x is greater than 7. So when you graph this one, they don't kind of connect, they go separate. Let's do another one. In this case, we have the absolute value of 2x minus 5 is greater than or equal to 3. So in order to solve it, we're going to have one where we get rid of the set of parentheses, or we're going to get rid of the absolute values. That's over here on the left. We just drop the absolute value. And on the right, you drop the absolute value. You make the everything to the right of the inequality negative, and you flip the sign. So we made everything to the right negative. We flipped our sign. Now we just solve them both. Add 5 to everything, because that'll cancel out this negative 5. Then divide everything by 2, and you get that x is greater than or equal to 4, or x is less than or equal to 1. So let's look at some absolute value inequalities with no solution, or sometimes where we have all solutions. So if we have a case, and this is true, if you ever see this, you don't have to do any work if you see something like this. So if you see something, sorry, I moved past it fast. If you see something like the absolute value is less than c, but c is negative, so if this was like a negative 4 and you have the absolute value is less than negative 4, that never has a solution. Or if you have the absolute value of something is greater than c and c is some negative number, that's always true. And that's kind of makes sense logistically, right? Absolute values are always positive numbers. So if you have a positive number, you can't ever have it be less than a negative number. And similarly, if you get a positive number, it's always going to be bigger than a negative number. So if you ever have the absolute value is greater than or less than a negative number, you could solve it without any work. This kind of is the part that I am not too worried about. This is a word problem. I'll leave it up here for a second, and you can pause it here if you want to look through it. But for me, I just don't think it's that important. So I just want to, again, if you want to look through this one, go ahead and pause it here. And then you can pause it again here. These are kind of your the work ones. This is another one too. But I think we've seen enough content in terms of absolute values in order to skip those. So like I said, we're going to do 4.4 next class, which will be on Thursday. That'll be the last video I post. And I'm also going to post your final and the instructions for that. Please get those turned into me. The sooner they get into me, the faster I can put your grades in and you can see how you did. And again, as long as you're handing everything into me, I don't want you to worry about your grades. Everybody's been doing well in terms of the content that I've been seeing. So please just make sure it gets into me. And if you have any questions, just let me know.